You've tracked the progress of 3I Atlas closely. It's recognized as the third object arriving from beyond our solar system. Its enormous scale, rapid velocity, and peculiar traits are familiar to you. Yet, the impending event on October 29th may escape your awareness. Within slightly more than 4 weeks, this entity will vanish from sight, concealed by the sun and undetectable by any terrestrial observatory. Harvard's astrophysicist Avi Loeb views this not as mere chance, but as a prime chance. Specifically, the chance for solar gravitational pull to redirect it into an enduring path, securing it eternally within our cosmic neighborhood. This is where the situation turns extraordinary. Over the past 2 days, fresh observations emerged. Its weight reaches a minimum of 33 billion tons, far exceeding prior estimates. The composition defies established scientific principles. Moreover, the emerald luminescence that has sparked widespread discussion occurred precisely when conditions rendered it inconceivable. Our examination of Loeb's complete discussion reveals all the irregularities, improbabilities, and probability, and grounds for doubting the official narrative as we dissect his assertions, the true implications of the evidence, and the consequences of 3I Atlas fading from view in 29 days. Regardless of whether you see it as an odd comet or a deliberate construct, one fact stands firm. The date of October 29th marks a potential turning point for all. It represents the critical phase for any adjustment, the irreversible threshold, and we shall explore precisely why Loeb advises scheduling leisure time prior to its arrival. Dive right in. Prior to that, should these thorough explorations appeal to you, please endorse with a like, join the subscription list, and share in the comments your location, local hour, plus the most bizarre incident from your life. Chapter 1. The shift arrives on October 29th, altering the landscape entirely. Begin with Avi Loeb's precise words from the session, since his opening stance reveals his entire perspective. He avoids conjecture at the outset. He skips any extraterrestrial theory. Instead, he launches with a figure, 20 kilometers. This represents his early assessment of 3I Atlas's dimensions, derived from its initial luminosity upon detection, a diameter of 20 kilometers. To illustrate, it surpasses Manhattan Island in extent. It doubles the dimensions of the impactor that struck Earth 66 million years back, extinguishing the dinosaurs. Such immensity suits ill an item presumed expelled from a distant stellar setup, wandering the cosmos indefinitely. At once, Loeb's thoughts turn to the probabilities. He remarks, "Consider the approximate quantity of solid debris present amid the stars. Estimates draw from observations of stellar birth zones, simulations of planetary assembly, and the prevalence of dense metals dispersed widely. Performing the calculations, determining the frequency with which an object of this magnitude would incidentally intersect our central solar zone yields a result. Once in 10,000 years, once in 10,000 years. Our dedicated hunt for extrasolar wanderers spans, say, 10 years? Perhaps extended slightly by including pre-technological eras for proper recognition. A single decade of scrutiny uncovers an item expected merely once per 10,000 years. Such probabilities, bluntly stated, appear odd. Yet Loeb advances beyond that. He notes our prior discoveries of 2 extrasolar items preceding 3I Atlas, Oumuamua in 2017 and Borisov in 2019. Each was modest in scale. Oumuamua measured around 100 millimeters in length, akin to a sports field. Borisov matched closely, spanning several hundred meters, ordinary if one deems any interstellar arrival commonplace. Spatial debris adheres to a standard progression. Small fragments vastly outnumber large ones. This stems from fundamental mechanics. During planetary genesis, as stellar clusters eject matter into the void between stars, the outcome. For each massive rock, there exist countless smaller stones, and for every grand peak, an immense array of such rocks. Thus, in terms of sheer odds, we ought to encounter vast numbers of modest visitors from beyond our solar system long before detecting any colossal one. Loeb estimates that prior to identifying an entity as enormous as Atlas, we should have already uncovered roughly 100,000 interstellar bodies comparable in scale to Oumuamua. Yet we've managed to spot just 2. One might contend that our observational techniques favor larger specimens. Perhaps the diminutive ones prove elusive, and Atlas emerged first solely due to its striking visibility and prominence. That critique holds merit, save for a single detail. Atlas displayed unexpected luminosity at the range where it was initially observed. Discovered on July 1, 2025, it lay far past Jupiter's path in a remote zone where solar illumination fades and celestial wanderers typically appear faint. At such distances, comets remain largely undetectable. Locked in icy rigidity, they float as mere fragments of frozen matter amid the chill void. Their signature hazy envelope of vapor and particles doesn't form until they near the Sun far more, often within Mars's orbital reach. Yet Atlas shone vividly, not subtly so. It gleamed with sufficient intensity for straightforward detection, prompting early assessments to presume it must be gigantic to scatter that volume of light. Imagine a beacon igniting amid the frozen wastes of Antarctica, utterly premature. In his discussion, Loeb emphasizes this peculiarity. He explains that comets generally require proximity to the Sun within roughly 5 astronomical units. That's equivalent to 5 times the span from Earth to our star, the threshold where stellar heat sufficiently vaporizes the frost, triggering the emissions that render them observable. Jupiter resides beyond 5 astronomical units. Atlas, however, radiated light from an even greater remove, exceeding what conditions should permit. This raises an early whisper of the extraterrestrial artifact notion. Perhaps it drew no warmth from the Sun. Perhaps it generated its own illumination. But hold off on leaping to conclusions. Trace Loeb's reasoning methodically, for here the evidence begins to accumulate. This marks the onset of alignments so precise they challenge the notion of mere chance. Next, Loeb examines the path it followed. Here, the case for deliberate calibration gains momentum. Upon entering our stellar neighborhood, an outsider from distant stars could approach from any bearing or slant. It has no cause to respect the flat disk of our world's yearly circuit. That's the layout of our system, irrelevant to its origin. Such a traveler should manifest at an arbitrary tilt and haphazard alignment, bearing no tie to our ecliptic. Atlas, though, defies that. Its course hugs the ecliptic to within 5 degrees, a mere 5 degrotons, remarkably level. It mirrors the orbital tracks of Earth, Mars, Venus, Jupiter, and the other inner worlds with uncanny precision. Loeb computes the odds of such randomness at 1 in 500, 1 chance in 500, unlikely yet feasible, sufficiently uncommon to warrant attention, sufficiently odd to provoke curiosity. Yet the alignment extends further, for Atlas doesn't merely parallel the plane, its route draws it near several worlds, strikingly near. On October 3rd, mere days ahead from this moment, Atlas will skim within 29 million kilometers of Mars. In cosmic scale, that's intimate. Near enough for NASA's Mars Reconnaissance Orbiter to attempt capturing it via the HiRISE camera. And the encounters continue. Atlas also ventures fairly close to Venus and Jupiter, each at orbital positions where the schedule serendipitously coincides with its transit. Loeb crunched these figures as well. He determined the joint likelihood that a wayfarer on a haphazard route would graze as intimately as Atlas does to consider the alignments of Jupiter, Mars, and Venus during those precise orbital configurations. The probability stands at 1 in 20,000. 1 in 20,000. Pause to reflect on that figure. This goes far beyond a single fluke. Instead, it involves a series of alignments piling up, combined with the object's unexpected scale and luminosity from such a remove. The synchronization with the ecliptic, the near encounters with 3 distinct planets, these elements might each pass as mere happenstance in isolation, yet collectively they defy easy dismissal. In the discussion, Loeb draws an analogy. He remarks that one could dismiss every separate detail as pure chance, the path as haphazard, the positioning as fortuitous, the approaches as serendipitous, the schedule as accidental. However, after repeated streaks of perfect outcomes, suspicion arises that the game might be rigged. Then comes his most compelling revelation, the detail that, should it hold, offers the strongest hint of deliberate design. Atlas reaches its nearest solar approach, the perihelion, on October 29th. Precisely then, our planet occupies the sun's far side. Observation becomes impossible. No earthly observatory can peer past the sun, blocking the line of sight to Atlas. It enters solar conjunction utterly concealed. Loeb suggests this setup might be deliberate, an ideal window for adjustment. If the goal involved harnessing solar gravity to decelerate, alter the course, or settle into a solar orbit undetected, this concealed interval behind the sun provides the cover. He terms it a reverse solar oath maneuver. Typically, probes exploit the oath effect for acceleration, igniting thrusters at peak velocity near a gravitational giant like the sun, where minimal propulsion yields maximal speed gain. Yet the inverse applies too. Engines could pulse to reduce velocity, dissipate momentum, and allow capture by gravity into a bound path. Should Atlas execute such a shift on October 29th, shielded from detection, it might secure a lasting place in our solar system. Rather than traversing and departing like typical interstellar visitors, it would circle the sun repeatedly, lingering in our cosmic vicinity forever. Loeb emphasizes how the perihelion timing, coupled with this precise invisibility from Earth, introduces yet more unlikelihood. Randomly tweaking Atlas's velocity by a small margin or displacing its arrival by mere weeks would rarely align the perihelion exactly opposite Earth's position across the sun. Conceivable, yet highly unlikely. Just one more element fitting with uncanny precision. Here, Loeb shifts to broader ramifications. He observes that if alien engineering underlies this, it selects the prime instant for intervention. The choicest spot for deceleration lies at perihelion, nearest the sun where gravitational pull peaks. Moreover, the sun itself veils it from scrutiny. Such strategy smacks of calculated stealth, precisely what one might employ to evade notice during navigational tweaks. Loeb presents this cautiously, as potential rather than fact, employing terms like could be, if technological, and this enables. He sketches a possibility, probes an idea, but the suggestion rings loud. The arrangement feels overly ideal, the schedule overly opportune, the path overly precise, and this merely scratches the surface of his case. Orbital dynamics form only the start. He has yet to address the optical data, the compositional oddities detected by Hubble and Webb, alongside other instruments monitoring the object these last 3 months. But from its path alone, it's evident why Loeb views this as warranting close scrutiny, why he believes we ought to entertain the chance that this isn't merely a stray celestial wanderer, but an entity driven by purpose. Chapter 2. Bigger than Manhattan. Thus, we must probe further into the scale issue, since the matter extends beyond Atlas merely being enormous. It concerns the implications of such dimensions for our grasp of interstellar travelers' dynamics, their anticipated frequency, and the discoveries we might have anticipated prior to encountering an entity of this magnitude. When Loeb references the 20-kilometer projection during his discussion, he draws upon those preliminary luminosity assessments. Astronomers determine a remote body's dimensions through a basic method at its core. They gauge the quantity of solar radiation it bounces back. They approximate the likely reflectivity of its exterior. That property is known as the albedo. Then, they reverse engineer the required extent to generate that level of returned illumination. For Atlas, those initial computations repeatedly yielded 20 kilometers, and Loeb swiftly identified that as an issue. Not due to 20 kilometers being unfeasible for a comet. We have observed comets of that scale within our solar system. Rather, detecting one so large as an extrasolar arrival so soon in our surveys violates the projected pattern. Consider the nature of cosmic remnants. Be they asteroids, comets, extrasolar fragments, or similar, they adhere to a power law pattern. This implies that larger items grow progressively scarcer, while tinier ones multiply dramatically. If a single boulder measures 10 kilometer wide, perhaps 100 measure 1 kilometer wide, 10,000 span 100 meter wide, and 1,000,000 reach 10 meter wide. The count surges with diminishing size. This trend permeates the natural world. It governs impact pit dimensions on the moon. It shapes seismic event intensities. It orders urban center sizes. Rare are the giants. Plentiful are the minors. The cosmos produces far more grains than peaks. Therefore, when Loeb analyzed figures for extrasolar bodies, he anticipated this regularity to persist. Should it apply, mirroring the power law observed universally, we would be inundated with minuscule extrasolar arrivals long before glimpsing a colossal one. We ought to have recorded thousands, perhaps tens of thousands, of Oumuamua-like specimens, those 100-nanometer class fragments, prior to chancing upon a behemoth like a 20-kilometer comet, yet we had not. We had identified precisely two. Oumuamua and Borisov, both diminutive, both spanning the 100 to few hundred nanometer spectrum. Then, suddenly, Atlas emerges, and it could boast a diameter 100 times greater, translating to thousands of times the bulk in terms of mass. Loeb articulates this in the discussion. He notes, given the limited reservoir of heavy elements in interstellar space, we should have discovered on the order of 100,000 interstellar objects on the scale of Oumuamua before finding Atlas. 100,000. Yet we had pinpointed only two extrasolar bodies to that point. At this juncture, the reasoning diverges. Several explanations could account for this mismatch. Perhaps our observational techniques falter markedly in detecting the petite varieties, leaving us to snare only the prominent luminous targets. That remains feasible. Instruments possess boundaries. Dim, compact stones prove elusive. Alternatively, the preliminary dimension assessment might have erred. Perhaps Atlas does not truly extend 20 kilometers. Conceivably, the observed glow stemmed from a source besides a vast, firm core mirroring sunlight. Perhaps it enveloped a vast haze of vapor and particles that amplified its apparent scale and radiance. And indeed, the latter scenario aligns more with prevailing views. Subsequent examinations, especially those via the Hubble Space Telescope, have sharpened the dimension appraisal substantially. As of late August, observations from the Hubble telescope indicated that the maximum possible width of Atlas reaches roughly 5.6 kilometers. That's substantial, certainly surpassing the scale of earlier interstellar travelers, yet far from 20 kilometers. Nothing like the size of Manhattan. A figure around 5.6 to 6 kilometers feels far more plausible. It's an oddity, no doubt, bigger than what we'd anticipate encountering so soon, but it fits plausibly as a natural comet. Such dimensions don't shatter the probabilistic framework as a 20-kilometer body would, yet this is precisely where the intrigue reignites. In the past few days, within the last 48 hours alone, fresh findings have emerged to muddy the waters once more. Loeb and his team released an updated study, still awaiting peer review, that scrutinizes Atlas's path with remarkable accuracy. They gathered inputs from 227 global observatories, totaling more than 4,000 distinct measurements collected across multiple months. Their work precisely charted Atlas's motion across the cosmos. The key discovery? Atlas exhibits virtually no deviation from gravitational influences alone. To grasp the significance, consider this. As a comet nears the sun and warms, its surface ice undergoes sublimation, shifting straight from solid to vapor that erupts outward. This expulsion from one side mimics a miniature thruster. It imparts a subtle shove, altering the path in manners pure gravity couldn't account for. Experts term this non-gravitational acceleration, a hallmark trait of comets in their active phase. Scientists detect it by monitoring the object's location over periods and contrasting it against predictions based solely on gravitational pull. A slight discrepancy, whether the comet lags or leads its expected spot, signals that venting gases are influencing its course. Based on this latest examination, Atlas displays almost no such effect. Its track aligns with a gravity-only orbit to extraordinarily precise degrees. The ceiling on any non-gravitational acceleration measures under 15 meters per day squared. That's minuscule. Far below the levels typical for a comet actively venting material. And evidence confirms Atlas is indeed venting. The Webb Space Telescope captured it on August 6th, quantifying the emissions from its exterior at about 150 kilograms per second. That's considerable substance, sufficient vapor to generate noticeable propulsion, enough to visibly shift the trajectory. So what explains the lack of shift? Why does Atlas behave as if gravity rules supreme, despite clearly ejecting gases? Loeb's explanation boils down to one factor: immense mass. If Atlas possesses sufficient heft, the outgassing thrust simply can't budge it appreciably. Imagine directing a leaf blower at a massive ocean liner. The push exists, but the object's bulk renders the effect trivial. To quantify this, they ran the calculations. Accounting for the documented venting rate alongside the undetectable non-gravitational pull, they derived the smallest possible mass for Atlas. The result? At least 33 billion tons. A staggering 33 billion tons is the floor. Atlas must tip the scales at no less, or its own emissions would visibly alter its motion. Assuming a composition of rock and ice akin to typical comets with comparable density, one can derive a baseline size from that mass, and it exceeds 5 kilometers, potentially by a wide margin based on its true compactness. Thus, we circle back to a sizable entity, unlikely to hit 20 kilometers but assuredly at the upper range, undeniably bulkier than any prior interstellar visitor. Loeb highlights that this positions Atlas as 3 to 5 orders of magnitude heavier than Oumuamua or Borisov, a multiplier of 1 to 100,000 times in weight, and that loops us straight into the initial probabilistic puzzle. If Atlas truly carries this much mass, detecting it so promptly amid our interstellar cataloging efforts is, in Loeb's, this stands out as a profound irregularity, akin to tossing a coin and landing on heads repeatedly for 1,000 consecutive tries. Is such an event feasible in theory? Absolutely. Does probability favor it? Hardly. Yet, there's an alternative lens through which to view that staggering 33 billion ton figure, another angle that Loeb alludes to without fully embracing during the discussion. Suppose Atlas lacks a dense uniform core. Imagine it as empty inside. Picture it as an enclosure, a framework boasting substantial bulk yet minimal density. Constructing a vessel for journeys across the stars demands more than forging it from unbroken alloy. Such an approach would prove absurdly burdensome, prohibitively costly in propulsion efforts to speed up or slow down. Instead, one would craft an outer casing, a slender boundary enclosing vast interior voids. That's the principle behind earthly vessels. Nature employs it as well. Skeletal frames contain cavities, vegetal stalks feature hollow cores. This method delivers robustness minus excess load. An emptied form spanning 10, 15, or perhaps 20 kilometers across might readily tip the scales at 33 billion tons, provided the enclosing layer holds sufficient depth. From afar, it would mimic a colossal monolith. It would scatter solar rays like any hefty boulder, yet defy expectations when assessing its heft. Loeb avoids stating this outright in the talk. He circles the notion cautiously. He muses on avoiding superficial judgments, on how the detected carbon dioxide and frozen water atop Atlas's skin might simply represent accumulations gathered amid its voyage across the cosmos. Essentially, a layer of rime on a glass pane. Still, the suggestion lingers. Should one entertain the prospect of Atlas bearing artificial origins, that 33 billion ton weight shifts from baffling outlier to telling detail. It's weighty, yet falls short of what a compact stone of comparable scale would demand. Substantial enough to counterbalance the push from vapor releases, yet feasible enough to envision as engineered rather than birthed by cosmic forces. Here, Loeb's reasoning evolves from isolated clue to tangled array of peculiarities. The dimensions seem off. The course appears peculiar. The arrival timing feels uncanny. The absence of extra motion, despite evident emissions, strikes as odd. No single element seals the case. Collectively, however, they sketch an entity that resists easy categorization. Loeb confronts this discord head-on. He concedes that the overwhelming probability points to Atlas as a pure interstellar wanderer, likely a comet. He asserts no guarantees. He stops short of declaring it extraterrestrial craft, yet insists the current observations fail to dismiss the possibility outright. For him, that suffices to merit deeper scrutiny. It calls for deploying all available scopes, probes, and monitoring devices to probe this visitor before it departs. Interstellar travelers, after all, prove transient. They sweep by, then vanish into the expanse, beyond reach for the span of our species' existence. Should Atlas turn out merely cometary, we'd glean insights into icy bodies from distant suns, knowledge of real worth. But if it harbors another nature, if even a slim 1% odds suggest otherwise, then foregoing a thorough examination would rank among humankind's gravest oversights. Thus concludes the scale debate. Thus, the density dilemma. Atlas looms large, likely outsizing what we'd anticipate for an early detected cosmic drifter. It carries at least 33 billion tons, though perhaps shy of a full stone's quota for its girth. Paired with its path and schedule, these traits render it sufficiently enigmatic to echo Loeb's persistent query. What if? Chapter 3. The orbit displays exquisite calibration. Now, consider the route this entity traces across our star system, for herein lies the precision. The case gains real traction as Loeb delves into the path breakdown during his discussion, far beyond highlighting a single fluke. He's piling them up, one stratum upon another of celestial paths that, viewed alone, appear improbable yet feasible, but collectively suggest intent. Start with the match to the ecliptic plane. Our star system remains fairly level. The 8 planets circle the Sun in nearly the same layer, akin to a platter centered on the Sun. Known as the ecliptic, this layer serves as a core structuring element in our nearby space region. All that originated locally, all that gathered from the ancient protoplanetary disk eons back, retains that layout. Asteroids largely follow paths close to the ecliptic. Comets from the Kuiper belt deviate, but maintain a loose tie to it. Interstellar objects, however, ought to disregard it. They hail from distant stellar setups with their distinct layers, alignments, and spin directions. An arrival from afar should approach from an arbitrary bearing at an arbitrary inclination. The likelihood of it matching our ecliptic plane so neatly is low. Feasible, yet low. Loeb pegs it at roughly 1 in 500, a 0.2% probability. Scanning 500 arbitrary interstellar objects, you'd anticipate just one aligning this precisely through sheer luck. Atlas marks only the 3rd such visitor we've detected. Thus, we're already facing odds around 500 against 3. Improbable, yet not outrageous. Layer on the near passes next. Atlas doesn't merely traverse the solar system at some haphazard remove from the planets. It brushes near 3, Mars, Venus, and Jupiter, and not solely near in position, but near in timing too. It reaches each planet's path precisely when that world occupies a proximate spot. Consider the demands of that scenario. The planets keep shifting. Mars requires about 687 days per sun loop. Venus needs 225 days. Jupiter spans 12 years. They occupy varied radii, travel at varied paces, and occupy precise positions only at precise moments. For an interstellar visitor to graze all 3 amid its passage, the schedule must align flawlessly. Loeb crunched those figures as well. He examined Atlas's route and computed the shortest separations it attains against each planet's path, not merely spatially, but factoring in the planet's actual locations as Atlas sweeps by. The joint odds of these 3 grazes occurring randomly, assuming a haphazard entry moment and course, total about 1 in 20,000. 1 in 20,000, no longer mere 500 to 1 shots. Now it's thousands upon thousands to 1. And that covers only the planetary brushes. It excludes the ecliptic match, another independent chance factor. On October 3rd, mere days away, Atlas will skim within roughly 29 million kilometers of Mars. In vast scales, that's practically a brush. Near enough that NASA intends to deploy the HiRISE camera aboard the Mars Reconnaissance Orbiter for direct shots of Atlas. High can capture the Martian terrain at superb detail, sharp enough to reveal single rocks and rover paths. Aiming it at Atlas promises our clearest view so far of the object's true form, possibly distinguishing the core from the encircling haze and particle veil. Yet the most intriguing detail lies here. The minimal orbit crossing gap, the nearest Atlas's path draws to Mars's full orbital track, measures a mere 2.7 million kilometers. 2.7 million. That's a negligible slit by stellar measures. A minor tweak to Atlas's path, a slight delay or advance in arrival, or a mere handful of degrees in tilt, and it might have drawn even nearer. It might have crossed Mars's orbit at a low highlights this detail during the discussion. He remarks, Such precise calibration, including the near pass by Mars alongside those to Venus and Jupiter, indicates a path that's remarkably fortuitous or deliberately orchestrated. Should intent drive it, the Mars rendezvous on October 3rd could transcend a mere skim. It could represent a chance. A chance for what, precisely? At that juncture, conjecture takes over. Loeb proposes that should Atlas qualify as an engineered artifact, like a vessel or explorer, its proximity to Mars would offer a prime occasion for launching an auxiliary, perhaps a compact explorer, a surface module, or a reconnaissance unit. One might dispatch an adjunct item requiring only slight trajectory adjustment to collide with Mars as the primary form presses onward to the Sun. He goes so far as to compute the specifics. Should Atlas dispatch an advance explorer veering forward and laterally by roughly 30 million kilometers, that explorer might arrive at Mars near October 3rd, coinciding with Atlas's minimal separation. The required launch velocity stays modest, merely a few kilometers attainable via basic thrusters. Moreover, Earth observers would miss it entirely. Detecting such diminutive items at that range lies beyond our capabilities. Telescopes discern features as fine as perhaps 10 or 20 meters at Jupiter's range, yet nothing tinier, especially if evasion forms part of the design. Does proof exist that Atlas has released any such item? Absolutely not. Pure hypothesis prevails here, yet Loeb urges vigilance. We ought to scrutinize Mars intently through and beyond the October 3rd brush. Should oddities appear in Mars's vicinity, or should orbiting craft register irregularities, such findings would carry weight. Beyond that lies the Venus transit. Atlas approaches Venus fairly snugly, albeit less so than Mars. Jupiter, positioned deeper in its path, experiences a brush too, albeit more remote. That these three align in one sweep of the solar system's core strikes as probabilistically rare once more. Feasible, yet rare. Yet the perihelion schedule, when Atlas nears the Sun most intimately, draws Loeb's keenest scrutiny. For perihelion falls on October 29th, placing Earth squarely across the Sun's face on that day. Atlas enters solar conjunction then. Visibility vanishes. All Earthbound scopes face solar obstruction head-on. Orbital instruments, immune to day-night cycles, still falter amid the Sun's radiant interference overwhelming adjacent voids. Loeb dubs this a concealed observatory. He contends that for plotting a path permitting undetected adjustment, none surpasses it. Parhelion suits a deceleration ploy ideally, given the Sun's peak gravitational pull there. Plus, the Earth effect, wherein orbital dynamics boosts propulsion amid high-speed proximity to a hefty body, reverses here. Engines could ignite to decelerate, shedding speed with solar pull aiding insertion into a stable path. Should Atlas seek permanence, shifting from hyperbolic outbound arc to elliptical tethered loop, October 29th marks the ideal juncture, shielded from our gaze. Discovery would dawn only later, as Atlas surfaces past the Sun in late November or early December. Trajectory recomputation would then reveal its halted departure. Does Atlas possess thrusters? Might it alter course? Utter mystery surrounds this. Propulsion signs elude us. No thermal traces, no vapor trails, no hallmarks of combustion engines. Yet for a sophisticated society crafting star-spanning scouts, crude fiery chemical boosters seem improbable. Far likelier, subtler mechanisms, ion drives perhaps, or magnetic propulsion devices, or drive mechanisms beyond our current imagination. The key idea is that an artifact from advanced technology need not resemble a vessel straight out of speculative fiction. It lacks the need for luminous thrusters or navigational beacons. Instead, it might resemble a mere asteroid. Enveloped in layers of frost and debris, shielded and disguised, it could execute minor course corrections that escape detection unless scrutinized with utmost vigilance. In the discussion, Loeb recognizes this potential. He stresses the importance of vigilant oversight of Atlas as it nears its solar closest point. Every operational vessel and sensor in the inner reaches of our star system must contribute to the most accurate tracking feasible. The European Space Agency's JUICE mission, en route to Jupiter, will offer a clear vantage on Atlas come November. NASA's Juno, presently circling the gas giant, could potentially capture sightings afterward. Orbiters around Mars will monitor its path in the initial days of October. We ought to deploy all resources at our disposal toward this enigma to ensure no detail slips by. Should Atlas execute a deviation on October 29th, decelerating to assume an orbital path, the consequences would be profound. It would signal the arrival of an entity not merely transiting our domain. It would indicate a presence establishing itself, an intruder claiming territory within our stellar neighborhood. From its reappearance in late November, we would have roughly 6 weeks until its nearest Earth encounter in late December to discern its nature and intentions. Loeb tempers this outlook by presenting it as an unlikely prospect. He maintains that the predominant expectation remains Atlas as an ordinary icy wanderer, traversing and departing like prior extrasolar visitors. Yet he insists that even this slim chance warrants rigorous scrutiny, given that the penalty for oversight, overlooking a true engineered arrival due to hasty rejection, vastly outweighs the effort of exhaustive examination revealing merely a celestial rock. This forms the core of his reasoning. Not that Atlas is assuredly extraterrestrial engineering, rather, the observations to date fail to exclude such an origin. Its path proves anomalous to a degree demanding intense observation. The positioning along the ecliptic plane, the sequence of planetary flybys, the scheduling of perihelion, all combine to depict an entity either extraordinarily fortuitous or adhering to deliberate design. During the exchange, Loeb draws on a casino metaphor. He notes, entering a gaming hall and witnessing a player achieve double sixes across 10 consecutive throws doesn't prompt instant suspicion of rigged equipment. Such fortune can occur. The probability sits around 1 in 60 million, yet it's conceivable. Still, upon observing it, one would likely seek a thorough inspection of the cubes. One would probe for irregularities. That's precisely his request. Let's examine more closely. Let's inspect the cubes. The route of Atlas, the precisely calibrated route weaving through our solar expanse, represents one of those instances where successions of perfect outcomes arise. Loeb voices emphatically and insistently that we must at minimum entertain the notion that the play isn't wholly governed by chance. Chapter 4. Absence of a train, presence of forward beams. Now, let's address the actual appearance of Atlas, as this is the juncture where optical data conflicts with standard expectations for such wanderers. It's also the spot where Loeb delivers one of his boldest assertions in the talk concerning forward illumination. Standard comets prove straightforward to spot, Loeb explains. Much as zebras stand out via their patterns, these bodies reveal themselves through their extensions. Such appendages define their essence. Nearing the sun and warming, surface ices convert straight from frozen state to vapor, termed sublimation. This generates a luminous envelope of vapor and particles encircling the core, known as a coma, along with an extension trailing the body, driven by stellar winds and photonic forces. That extension invariably orients opposite the sun. Invariably. Direction of motion holds no sway. A celestial body in motion reveals its tail, shaped by solar rays and the stream of charged particles from the star. This appendage flows away from the sun's position, resembling strands of hair caught in a gentle wind. Such a feature allows for immediate recognition of these wanderers. Spot the hazy form, observe the tail's alignment, and its direction immediately reveals the sun's location in relation to the body. Yet, during the Hubble Space Telescope's observation of Atlas on July 21st, an anomaly appeared. The instrument recorded a droplet-like envelope of particles emanating from the core, with a subtle suggestion of a tail, though its alignment seemed off. Rather than a distinct streamer extending sunward in retreat, scattered illumination stretched in the sun's direction, oriented ahead as if the body sported forward beams rather than a trailing wake. Prior to delving deeper into this observation, caution is essential in analyzing views from distant lenses. The study of stars demands precision. Capturing an entity racing across vast voids at cosmic velocities, separated by millions of miles, hinges on timing the shutter. The subject shifts position while the image forms, leading to blurring from its path. This results in a luminous streak along its trajectory. Should that path align toward the sun, it might mimic an advancing radiance, merely an illusion from the shift. Experts at NASA promptly highlighted this possibility. They explained that the seeming protrusion sunward in the Hubble view probably stemmed from the capture technique itself. As the body sped sunward with increasing pace, the telescope followed its course amid the recording, causing fixed lights in the backdrop to elongate and possibly forging an illusory leading streamer. However, Loeb remained skeptical. He collaborated on a study with peers, questioning if Atlas might represent extraterrestrial craft. Among their supporting observations was this peculiar leading shine. They contended that although trail distortions might account for some aspects, the intensity and form of the protrusion failed to align fully with simple path-induced haze. Then, toward the end of August, a noteworthy development occurred. The Gemini South Observatory in Chile obtained fresh views of Atlas. On this occasion, a definite tail emerged, a subtle streamer flowing sunward in the anticipated manner. Come late August, Atlas exhibited typical wanderer traits without deviation. Those who examined the captures declared it validated their prior assumptions. Atlas qualifies as a comet. It releases vapors. It forms a hazy envelope in a streamer. Matter settled, yet Loeb notes the sequence of events raises questions. In the initial 6 weeks following its detection, Atlas displayed unclear optical traits: the leading shine, absence of a distinct streamer, exceptional luminosity for something so remote from the sun. Subsequently, just as it passed within Mars's path and stellar warmth intensified markedly, it began resembling a standard comet. In his discussion, he draws on a literary comparison. He advises against assessing a volume solely by its exterior. Atlas's current possession of a wanderer streamer does not inevitably reveal its inner nature. The outer layer might bear layers of frozen water and particles gathered over its voyage across the void between stars, like ice forming on a vehicle's glass. When that layer turns to gas under the sun's influence, it generates the precise streamer associated with comets, regardless of whether the core consists of ordinary frozen debris and stone. Such ideas remain hypothetical. Clearly, no concrete proof exists that Atlas harbors an atypical makeup below its shell. Still, the claim holds that outward visuals provide insufficient certainty. An artificial construct journeying through the cosmos for eons would gather remnants, gases from the spaces between stars, frozen bits, specks from the universe. These would adhere to its exterior and solidify. Upon reaching a new stellar realm, it would appear as a comet externally, despite differing internally. Moreover, consider the emerald luminescence. This represents one among the latest discoveries. This shift remains truly baffling, even for experts utterly certain that Atlas remains a genuine celestial body. During the total lunar eclipse on September 7th, a pair of astrophotographers in Namibia snapped photos of Atlas amid exceptionally shadowy conditions. With the moon fully obscured, a primary culprit of sky glare vanished entirely, allowing for prolonged shots of the comet. Their findings proved remarkable. The object shone with a bright emerald hue, an intense and clear verdant light. Such verdant comets do occur occasionally. History records prior instances. Typically, this tint arises from diatomic carbon, consisting of a pair of linked carbon atoms forming a molecule. Upon exposure to solar ultraviolet rays, diatomic carbon fluoresces, releasing light visible in the spectrum's green range. This mirrors the mechanism inside a fluorescent bulb, where input energy at a specific wavelength yields output at a different one. Thus, a comet's emerald radiance generally indicates diatomic carbon within its surrounding haze, generated through the vaporization of surface organics. No oddity here, no irregularity, save for the fact that spectrum analyses of Atlas from merely a month prior, in early August, revealed scant diatomic carbon. Indeed, researchers at Arizona's Kitt Peak Observatory determined Atlas to rank among the most deficient in carbon chains of any recorded comet. Its quantities of green-emitting molecules sat at unusually minimal levels. Then, why the September emerald shift? From whence originated the diatomic carbon? A plausible account suggests it lingered all along, merely concealed under the outer layer. As Atlas neared the sun and warmth escalated, inner icy strata thawed, unveiling untouched substances richer in carbon elements. That emerald shine might signal access to previously sealed core ices. An alternative view, advanced by Loeb in a subsequent blog entry following the emerald shot's release, posits the shade stems not from diatomic carbon whatsoever. Perhaps it's cyanide instead. Chile's Very Large Telescope observed a sharp surge in Atlas's cyanide output toward August's end, spiking sharply with solar proximity. Under suitable circumstances, cyanide too yields a verdant tint. Should levels prove sufficiently elevated, it could account for the striking shade seized amid the eclipse. Yet a further option exists, considerably more conjectural, yet deserving note for linking to the wider array of irregularities. Suppose the emerald radiance signals a form of ignition. Imagine if Atlas, regardless of its true nature, surpassed a solar warmth boundary that sparked an alteration in its conduct. Loeb avoids stating this outright in his discussion, though the hint lingers. In later publications, he describes the hue's alteration as abrupt. It seemed like a boundary response, not a slow evolution. Abruptly absent emerald, then abruptly brilliant emerald, akin to toggling a lever. Should Atlas constitute a dormant artifact, navigating the chill void between stars across eons, it would require a revival method upon entering a fresh stellar domain. Heat serves as a clear catalyst. Nearing the sun with mounting surface warmth, mechanisms might energize, devices might engage, yielding side effects, thermal output, radiance, or molecular releases that we might mistake for standard cometary venting. Pure hypothesis, of course, lacking solid proof, yet it aligns with the recurring quirks Loeb persistently underscores. Atlas mimics a comet closely, yet imperfectly. It displays nearly all anticipated traits, laced with peculiar deviations. A trailing extension that emerges tardily, an anterior shine absent from expectations, a spectral shift clashing with prior readings. While each quirk admits a feasible earthly rationale alone, collectively they sketch an image of it resembles an entity straining to mimic a comet, yet falling short in the effort. Regarding its makeup at the molecular level, the James Webb Space Telescope examined Atlas on August 6th and employed spectroscopy to scrutinize the vapors within its surrounding haze. The discovery proved peculiar. The proportion of carbon dioxide to water ice stands at 8.1, precisely 8.1. This marks one of the most elevated such proportions documented for any comet, whether typical or atypical. Comets within our solar system generally feature far greater quantities of water ice compared to carbon dioxide ice. Water abounds universally. It permeates all observed frozen entities. Every frozen form we have probed, ranging from comets to Jupiter's satellites to Saturn's ring systems, consists predominantly of water ice laced with minor other substances. Atlas defies this pattern entirely. Carbon dioxide prevails in it, accompanied by merely a trace of water. What accounts for such a deviation? A possible rationale suggests that Atlas originated in an exceedingly frigid region of its originating stellar setup, distant from its central star, where carbon dioxide ice endures stably while water ice evaporates gradually across eons. It might truly date back to antiquity, predating our own solar system, originating from a star born in an earlier galactic era with altered elemental distributions. An alternative view posits the carbon dioxide as a newer accumulation, a layer of frost that accumulated on the exterior amid Atlas's transit across the void between stars. Clouds of gas in interstellar realms harbor carbon dioxide. Should Atlas have traversed one, particles might have adhered to its chilled exterior, gradually forming a sheath of CO2 ice. Alternatively, as Loeb contends in his reasoning, the CO2 might serve as an intentional barrier, a crafted overlay intended to safeguard the core and control thermal fluctuations during voyages across stellar expanses. Carbon dioxide ice exhibits distinct heat-handling traits from water ice. It transitions to gas at varying thresholds, scatters illumination in unique fashions, and defends against radiant energies through particular mechanisms. In designing a craft to endure the rigors of interstellar voids, one could select CO2 to integrate into strategies for managing heat. This notion ventures into conjecture, yet it remains grounded in physical plausibility. Carbon dioxide ice indeed operates unlike water ice in behavior. It can establish enduring layers under suitable circumstances, and any form enduring cosmic journeys over vast timescales would require defenses against radiant assaults, tiny impacts from debris, and swings in environmental temperatures. Loeb persistently underscores that presumptions serve no purpose. Surface elemental makeup alone cannot reveal the full nature of the interior. The 8:1 proportion stands out as anomalous. It merits attention, it demands further scrutiny, yet it neither confirms Atlas as a natural phenomenon, nor establishes it as engineered. It simply adds to an accumulating array of observations that challenge conventional interpretations. Chapter 5. Does it represent extraterrestrial engineering? Let us confront the inquiry head-on, the one Loeb raises in his publication and delves into across the discussion. Is Oumuamua like Atlas the product of alien ingenuity? Not merely if it could be, or perhaps is, but what indicators would compel us to determine that it truly is? Here, Loeb's method gains intrigue as he avoids mere fanciful guesses. He seeks to construct a structure, a systematic approach, a mindset for evaluating wanderers from beyond our system, one that avoids knee-jerk natural attributions while refraining from hasty, otherworldly judgments, absent proof. During the exchange, Loeb describes a concept he terms the Loeb scale. This constitutes a scoring mechanism from 0 to 10, which he suggests for gauging interstellar visitors according to their potential as artifacts over mere geology. A score of 0 denotes an entity fully embodying the traits of a routine comet or asteroid. It displays a coma. It releases gases in expected patterns. Its path aligns with gravitational pulls and propulsion influences as anticipated. Its elemental profile fits norms, no oddities, nothing noteworthy. A score of 10 signifies an entity unmistakably artificial. It executes motions. Phenomena defying conventional physics mark the pinnacle of this assessment framework. Such an entity broadcasts emissions. Detailed imagery reveals engineered configurations. Thermal output exceeds what sunlight alone could produce, implying an onboard energy mechanism. Behaviors emerge that unmistakably signal deliberate design, erasing any ambiguity. Intermediate cases form a spectrum. Items exhibiting a single or dual oddities could score 3 or 4. Entities displaying numerous baffling traits, with improbabilities accumulating, may climb to 6 or 7. The concept revolves around anticipating a surge in cosmic interlopers over the next decade, which is inevitable. The Vera Rubin Observatory, upon reaching full capacity, should detect one roughly every several months, necessitating a standardized method for appraisal, akin to a sorting mechanism. This allows discernment between those meriting deep analysis and mere cosmic debris drifting by. Loeb proposes that scores surpassing 5 on this metric ought to prompt a worldwide reaction, not alarm or armed readiness, but a unified scholarly initiative. Deploy all telescopes at hand, every probe, each monitoring device to examine it closely. Share findings across borders, since Loeb observes that extraterrestrials disregard territorial lines. Discovery by any country or oversight by any authority holds no relevance to them. A cosmic intruder poses a collective human challenge demanding a planetary approach. He advances the notion even more. An entity, a global entity, ought to exist, dedicated to surveilling these wanderers from afar and determining reactions should any exhibit signs of artifice. Currently, none such operates. NASA exists, ESR operates, alongside diverse country-specific space entities, monitoring Earth-proximate bodies and guarding against meteor collisions, yet no cohesive guideline addresses spotting an extrasolar artifact. Loeb contends such a framework is essential given the fleeting time frame. These far-flung travelers zip through space. Upon detection, they frequently lurk far within our stellar domain, affording mere weeks or months for observation prior to departure. Squandering those moments in disputes over leadership or investigative merit forfeits the opportunity forever. He likens this to broader perils facing existence. Concerns over synthetic intellect abound, forums convene, scholarly centers thrive, Official panels formed to ensure machine evolution avoids unintended human detriment. Climate shifts provoke anxiety. Pacts span nations, accords bind them, gatherings align strategies. Even meteor strikes unsettle us. NASA maintains a defense initiative tailored to catalog risky bodies and devise deflection techniques. Extraterrestrial artifacts? Zilch. No entity, no guideline, no strategy. Loeb deems this perplexing. He asserts that despite slim odds, say a mere 1% likelihood of an extrasolar body being crafted, the stakes loom so vast that readiness is imperative. Unlike faint broadcasts from distant suns, light years removed, offering ample leisure for reflection, discussion, and scheming, a nearby intruder demands swift measures. Thus, how does Atlas rank on the Loeb scale? The discussion avoids a precise figure, yet inferring from hints, it likely hovers near 5 or 6, far from confirmed as engineered, yet sufficiently irregular to demand rigorous focus. Its path deviates from norms, density surpasses predictions, optical traits intrigue, composition puzzles, isolated quirks may yield earthly rationales, but together they elevate Atlas beyond casual labeling as a mere icy wanderer. This captures the essence of Loeb's plea. He avoids claiming Atlas as assuredly extraterrestrial. He argues that this object qualifies as a potential spacecraft, emphasizing its peculiarities to such an extent that vigilant monitoring is essential, along with readiness to entertain the chance it originates from artificial origins. Dismissing it too hastily, thereby overlooking a true extraterrestrial artifact, would represent a monumental blunder in historical terms. Furthermore, Loeb introduces a more ominous perspective, proposing that should Atlas prove artificial, it may harbor hostile intentions. He draws on the dark forest hypothesis, a notion from speculative fiction positing a cosmos teeming with advanced societies, yet all maintain silence since broadcasting one's existence invites peril. Without insight into alien motives or assurance against aggression, the prudent course involves concealment, positioning oneself as hunter rather than quarry. Within this paradigm, a probe from beyond the stars infiltrating a new stellar domain might serve as an exploratory vanguard, collecting data ahead of a main fleet's arrival, or, alternatively, as an assault's precursor, engineered to neutralize safeguards or unleash armaments prior to any awareness of the incursion. Loeb presents this scenario strictly as speculative musing, devoid of prophecy. During the discussion, he notes that Atlas might arrive as savior or scourge, urging preparation for either outcome. Yet the core message carries gravity. Encountering artificial evidence demands skepticism toward benevolence. Evaluation of its functions, path, and risk must occur swiftly before proximity eliminates choices. What choices exist? Precious few, in truth. Should Atlas constitute a spacecraft already navigating the solar system's core regions, halting it lies beyond our grasp. No armaments exist capable of shattering a 20-kilometer entity. No vessels could rendezvous with it, given its velocity. Communication emerges as the sole viable recourse. Dispatch transmissions, forge links, and trust its creators desire dialogue. Loeb advises that upon confirming Atlas's artificial nature, initiating contact via broadcast ranks among initial priorities. A basic greeting suffices: salutations, greetings to our cosmic locale, peaceful intentions affirmed, conventional protocols for initial encounters, then observe. Monitor for replies, track alterations in conduct indicating comprehension, yet this hinges on detecting artificial markers outright. Such detection poses a genuine hurdle. Our searches target phenomena aligning with preconceived notions of machinery, radio emissions, thermal traces, angular forms. However, a society advanced enough for interstellar craft could employ methods so superior to ours that artificiality evades notice. Arthur C. Clarke's renowned observation holds that technology sufficiently evolved appears akin to sorcery, a principle reversible in application. If Atlas stems from a culture eons, perhaps 1,000,000 years ahead, it could register as utterly organic to our tools. Propulsion might operate sans emissions. Signaling could employ undetectable channels. Composition. From substances emulating pristine stone and frost with flawless verisimilitude, might conceal its crafted essence, fooling us into attributing formation to haphazard cosmic events. Loeb confronts precisely this dilemma, establishing artificiality absent knowledge of feasible innovations, separating intent from happenstance with merely a solitary instance. His solution involves seeking anomalies, improbabilities serving purpose. An orbit grazing several worlds might stem from chance, yet mirrors the blueprint for planetary reconnaissance. Density sufficient to defy gravitational tugs, yet modest enough to imply engineered origins. A hollow framework might arise organically, yet it aligns precisely with the design of a crafted exterior. A layer of frozen carbon dioxide on the surface could emerge spontaneously, though it serves as a practical shield against heat. Individually, none of these features confirm suspicions, but together they hint at possibilities. Such clues warrant deeper inquiry, and the irritation expressed by Loeb during the discussion stems from the reluctance of many researchers to pose the question at all. They prefer to regard Atlas as a typical formation, catalog it as a noteworthy yet commonplace icy body, and proceed elsewhere. He describes this opposition, this form of exclusion, in stark terms. Conventional research frequently resists concepts that disrupt long-held stories, and the current story holds that wanderers from beyond our system consist of ordinary remnants, chunks of stone and frozen masses hurled from distant stellar nurseries amid world-building processes, proposals implying otherwise, suggesting artificial origins, face rejection as fringe notions or bids for notoriety. Loeb counters that inquiry must chase evidence rather than preconceptions. When observations suggest oddities, exploration is essential. Curiosity demands it. We ought to entertain unsettling theories, for the opposite path leads to mental rigidity, shutting out options merely because they appear improbable. Moreover, he notes that records abound with cases where the improbable proved accurate. The notion of drifting continents met ridicule until proof mounted irresistibly. The concept that our star, rather than our world, anchors the local cosmic arrangement faced condemnation as blasphemy until instruments verified it. Singularities in space, once mere theoretical oddities without tangible basis, gained acceptance only after detections began. The sequence repeats consistently. An individual advances a view clashing with accepted knowledge. Authorities dismiss it. Evidence builds steadily. In time, the fresh perspective prevails, and observers marvel at the delay in recognizing what retrospect deems evident. Loeb anticipates that extraterrestrial craft, engineered artifacts from remote systems, will trace a similar course. At present, the concept resides on the margins. The majority of experts deem it improbable or unattainable. Yet with the discovery of additional such travelers, with intensified scrutiny, with mounting irregularities, the proof will grow irrefutable. And upon that shift, Loeb aims to stand noted among those who engaged it earnestly from the outset. Chapter 6. The tally of mass fails to balance. Let us revisit the figures, for here Loeb's reasoning gains its firmest footing. The estimate of 33 billion tons represents more than an intriguing aside. It imposes a limit. It reveals core truths about Atlas's composition, its architecture, and the plausibility of its presence amid the known voids between stars. In the conversation, when Loeb addresses the mass inventory, he invokes a straightforward assessment. What quantity of solid matter lingers in the interstellar voids? And considering that total, with what frequency might we anticipate encounters with varying scale items traversing our cosmic neighborhood? Our galaxy harbors a defined portion of dense substances: carbon, silicon, iron, oxygen, the elements forming stones, worlds, and rubble. The bulk resides bound within suns and orbiting bodies. Portions wander as fine grains and tiny fragments through the gaps. From time to time, bits escape stellar clusters during world assembly, propelled outward by tugs from massive worlds, transforming into roaming refuse. Tallying all such expelled substance and spreading it through galactic expanse yields a measure of concentration, a modest figure in tons of stone per cubic light-year. Vastness dominates, with emptiness prevailing. Still, models of world creation and surveys of nascent systems allow reasonable projections. With the established density across star systems, determining the frequency of encounters for objects of specific dimensions with our own solar system becomes straightforward. Abundant smaller bodies imply regular sightings, whereas larger ones remain scarce, rendering detections exceptionally infrequent. This pattern adheres to a power law distribution, enabling predictions of occurrence rates for whatever scale piques interest. Regarding Atlas, Loeb's computation, starting from the preliminary 20-kilometer dimension, suggested sightings of such magnitude happen roughly once per 10,000 years. Even adjusting to 5 to 6 kilometers informed by the 33 billion ton mass, the incidence stays notably sparse, perhaps every 1,000 years or across several millennia, varying with the precise interstellar population framework employed. Yet in just 10 years of observation, we've detected it. This improbable timing forms the core statistical strain that Loeb persistently underscores. Imagine forecasting a singular exotic avian passing your vantage every millennium, only for it to appear right at the outset of your vigil. Is sheer fortune at play? Certainly possible. Infrequent occurrences do transpire, lottery jackpots claimed, bolts from the heavens descending. However, integrating this improbability alongside the prior auditors, the path, the schedule, the optical irregularities, shifts the impression from mere chance toward an alternative interpretation. An alternative reconciliation exists for this discord. Perhaps assessments of the interstellar mass inventory err on the conservative side. Conceivably, vast quantities of lithic remnants drift through the void beyond current projections. Should the interstellar refuse concentration surge by a factor of 10 or even 100, unearthing Atlas so promptly in our scan would scarcely raise eyebrows. Yet this adjustment spawns fresh dilemmas. Were vast interstellar realms teeming with sizable entities, additional discoveries ought to abound. The Vera Rubin Observatory activated in 2025, unearthing solar system asteroids by the thousands weekly. Should interstellar visitors proliferate, Rubin would detect them without respite. To date, however, it has identified merely a scattering of prospects, many pending validation. Thus, the mass inventory holds true with Atlas as a mere outlier, or it falters, heralding an imminent revelation of interstellar objects' greater prevalence. In any case, inconsistencies linger. Loeb favors yet another avenue. Atlas's exceptional heft stems not from dense stone, but from an engineered form, a casing, an enclosure, offering substantial enclosure yet minimal density. Such a configuration accounts for its 33 billion ton burden, sufficient to counter outgassing propulsion without matching the heft of a comparable compact body. Consider human-constructed vessels. The International Space Station spans immense proportions, yet registers light weight against its expanse, comprising largely void interiors framed by slender barriers. Observing it remotely and presuming uniform metallic solidity would inflate mass guesses extravagantly. Analogous dynamics might govern Atlas, a voided design, optimized for minimal load and maximal utility, aligns seamlessly with observed weight, sans enforced scarcity. This notion carries a drawback, though. Direct proof of Atlas's hollowness eludes us. Internal views remain inaccessible, structural depths unquantifiable. Trajectory records and mass inferences from absent non-gravitational deviations constitute our sole arsenal. These align equally with a monolithic body, albeit one of unforeseen density. Probing the core demands innovative means. Proximity-enabled radar could suffice, delving beneath exteriors to unveil hidden architectures. Solar system comets' innards have yielded to such tactics via radio signal rebounds and echo analyses. Alas, Atlas's remoteness thwarts Earth-based radar, and no proximate probes stand ready to attempt it. These risk the imaging device aboard the Mars Reconnaissance Orbiter, set to capture views of Atlas come October 3rd, lacks the capability to peer within bodies. Surface imaging is its sole function. Yet, it could yield valuable insights nonetheless. Should Atlas exhibit an odd form, excessive smoothness or geometric precision, or traits inconsistent with ordinary comets, such observations would carry weight. No definitive evidence, merely an additional clue. Loeb holds keen curiosity regarding the forthcoming high-rise visuals, owing to their potential to isolate the nucleus amid the coma. A key difficulty in comet studies lies in the luminous envelope of vapor and particles that envelops them, obscuring the dense heart. Envision snapping a picture of an illuminated bulb as a beam from a torch blinds you directly. Such radiance drowns out finer elements. High-rise, however, boasts exceptional clarity. Engineered to detect rocks on Mars's terrain, items spanning 1 or 2 meters, from orbital heights, it excels in precision. Directed toward Atlas at 29 million kilometers away, it ought to discern elements as fine as roughly 30 kilometers. Insufficient for scrutinizing textures, yet adequate to differentiate the core nucleus from its encircling coma and refine measurements of its dimensions. Should the nucleus measure over 5 kilometers, should high-rise verify that Atlas spans 10, 15, or even 20 kilometers in width, the mass allocation dilemma intensifies, since an entity of that scale, tipping the scales at just 33 billion tons, would demand construction from exceptionally airy materials, perhaps spongy ice or a bubbly framework diverging from standard comet makeup. In such a scenario, with Atlas emerging both unusually vast and remarkably lightweight, the notion of technological origins gains traction, unconfirmed yet credible. Loeb alludes succinctly to another facet of the mass allocation reasoning, one deserving deeper examination. The frequency of interstellar wanderers ought to hinge on the prevalence of planetary setups generating worlds and flinging remnants outward. Where world-building abounds, with planets orbiting most stars, encounters should occur often. Rare planetary development would mean sparse sightings. Contemporary understanding confirms planets' ubiquity. Surveys like Kepler and fellow exoplanet hunts demonstrate that stellar bodies commonly host planets, prompting mass allocation models to project abundant interstellar castaways. Countless planetary architectures over eons, spewing stones, comets, and hurling them across the cosmos. This process should foster a plentiful array of nomadic entities. Yet, if the bulk of such remnants consists of tiny fragments, grains, stones, perhaps spans akin to athletic fields, the larger specimens remain uncommon, positioning Atlas as an exception. Except, as Loeb proposes, if a portion of these interstellar arrivals defies natural origins entirely. Even a mere 1% comprising engineered scouts from galactic explorers would upend the figures. No vast reservoir of flung natural boulders proves necessary to account for an artificial arrival. A single society within the Milky Way, opting to dispatch scouts to proximate stellar realms, suffices. Considering the galaxy's stellar multitude and ancient timeline, such a prospect appears feasible. Here, Loeb's reasoning ties into the wider inquiry of alien minds. Solitude in the galaxy, Earth as the sole cradle of advanced society, would render all detected interstellar bodies mere stones and frosts, unremarkable. Yet, shared existence, with intellect widespread or sporadically emergent yet existent, implies certain interstellar bodies bear artificial marks, scouts, abandoned hulks, vintage vessels adrift in emptiness. Thus arises the puzzle, discerning the crafted from the innate clutter, identifying the manufactured amid organic noise. Loeb advocates methodical scrutiny. Rigorous approaches are essential. We must examine each interstellar visitor with utmost scrutiny. We must assess their characteristics, monitor their paths, detect any irregularities, and pursue detailed probes whenever the weight, route, or composition seems amiss, since overlooking a true artificial intruder could rank among humanity's gravest oversights. With its staggering 33 billion-ton mass alongside numerous peculiarities, Atlas embodies the precise sort of enigma warranting such intensive scrutiny. It defies clear classification as purely organic. It eludes straightforward identification as engineered. It lingers in that ambiguous realm where definitive judgments prove elusive in both directions. Such ambiguity, Loeb contends, justifies vigilant oversight without delay. Chapter 7. Pine the Sun. The pivotal date arrives on October 29th. That's when Atlas attains perihelion, its nearest approach to the Sun, vanishing from sight obscured by our star. According to Loeb, this represents far more than a mere blind spot in monitoring. It stands as potentially the crucial juncture across the whole event. At perihelion, an object encounters the sun's gravitational pull at peak intensity. Speed surges to maximum. The orbital arc bends most acutely. If altering one's path demands a significant adjustment, whether decelerating, accelerating, or redirecting, that's the optimal instant to act. There, minimal propulsion yields the greatest shift in direction. Known as the Orth effect, this core tenet of orbital dynamics informs every mission architect's playbook. Typically, engineers exploit the Orth effect for acceleration. They ignite thrusters amid peak velocity, nearest a dominant mass such as the sun or a planet, maximizing the value of injected kinetic energy. Missions like Pioneer and Voyager, along with all our deep space explorers, harness slingshot boosts and precisely scheduled firings at perihelion to build momentum and arrive at distant targets. Yet the principle flips effectively too. It enables deceleration, braking, velocity dissipation, and gravitational ensnarement into a stable loop rather than a fleeing arc. Termed a reverse Oerth maneuver, this tactic precisely suits any intent to evolve from a fleeting stellar transit into a lasting residence within the system. Atlas follows a hyperbolic course right now. That implies it exceeds escape speed. It will arc past the sun and resume its interstellar journey. Barring intervention, barring a perihelion slowdown, the alignment proves strikingly fortuitous. On October 29th, as Atlas hits perihelion, Earth positions itself precisely antipodal across the sun. We enter solar conjunction then. The sun interposes squarely between our world and the object, its radiance overwhelming all signals. Terrestrial observatories face total blackout. Orbital instruments like Hubble and Webb, immune to earthly light cycles, still falter amid the sun's enveloping halo and glare, rendering captures near the solar limb virtually unattainable. Loeb portrays this setup as a concealed observatory slot. Crafting a flight plan for stealthy path tweaks would spotlight exactly this scenario. One times arrival at perihelion, while the realm boasting premier scopes and keenest pursuit hunkers on the star's remote flank. One executes the adjustment amid universal distraction. Does deliberation shape this? Does purpose guide it? Or does mere chance weave yet another link in an escalating chain of flukes? Tweak Atlas's velocity marginally, nudge its perihelion timing by days or weeks, and the odds of Earth aligning opposite the sun at that precise beat dwindle sharply. Not zero, yet slim. Roughly 1 in 20, varying by method. Simply one more unlikely layer atop the mounting pile. Yet, consider the truly remarkable aspect here. Should Atlas execute any adjustment on October 29th, perhaps igniting its thrusters or employing another means of deceleration to settle into a solar orbit, we'd lack instant awareness. Discovery would come only after several weeks, as it swings back into sight from the sun's glare during late November or early December, prompting a fresh path analysis. Then, should its path show alteration, with Atlas shifting from a fleeing course to a looping ellipse confined within the solar system, evidence of intervention would emerge. We'd recognize that some adjustment took place, though details like timing, method, or propulsion type would remain elusive. Our sole clues would be the incoming arc contrasted against the outgoing one. According to Loeb's estimates, a successful self-insertion by Atlas into such a tethered path might propel it toward Earth with surprising speed. His projected schedule points to late November through early December for the nearest pass by our world. This proximity wouldn't imply impact. Atlas would maintain a distance of millions of kilometers, yet it would afford far superior scrutiny than our current vantage. Such developments inevitably prompt inquiries about motives. Assuming Atlas possesses artificial origins, functioning as a scout or vessel of extraterrestrial design, what drives it? Why elect to linger in the solar system rather than merely traverse it? Among the theories stands surveillance. An emissary crafted for examining life-bearing planets would seek prolonged presence. It might circle at a safe remove, attuned to capture electromagnetic signals, detect markers of manufacturing, and follow the paths of vessels and orbital platforms. Over spans of months or years, it could amass insights, assembling a thorough profile of the society it encounters. A further option involves procurement of assets. Our solar realm brims with valuable substances, frozen water on icy bodies and satellites, ore-laden rocks, helium-3 suspended in the gaseous envelopes of colossal worlds. A sophisticated society could dispatch envoys to survey stockpiles across stellar domains, pinpointing prospects for later harvesting. Alternatively, the aim might lean toward protection. An automaton sensing signs of advancement or sentient activity could carry directives to neutralize it preemptively, averting potential peril. This echoes the shadowed woodland hypothesis invoked by Loeb, the notion that broadcasting one's presence risks peril from unknown peers, given the uncertainty of their agendas. Thus, the prudent course entails eradicating nascent minds before they gain the means to pose a challenge. Loeb takes pains to clarify that he avoids forecasting such outcomes. He refrains from labeling Atlas a device of harm or declaring us under immediate peril. Still, he urges that encountering artificial elements demands exploring every scenario, even adversarial paths. Blind faith in harmless aims proves unwise. On a brighter note, should we deem it so, advance notice awaits us. If Atlas opts to remain bound here, securing an orbit and veering our way, its advance would become visible. We'd gain weeks or months to scrutinize its motions, attempt contact, and discern its objectives and designs. This contrasts sharply with an abrupt emergence leaving no room for response. Yet the span for such vigilance proves limited. Spanning from Atlas's late November unveiling to its late December Earth skim, our time frame spans roughly 4 to 6 weeks. Throughout, unrelenting scrutiny remains essential. Every observatory, orbital craft, and detection tool must train upon it. In the discussion, Loeb notes that NASA's Juno, now circling Jupiter, could catch glimpses of Atlas during its March 2026 Jupiter flyby. ESA's JUICE mission stands ready for sightings in November. Craft around Mars could monitor it come early October. Uniting these resources, extracting the observations, and ensuring seamless integration must guide our efforts. Because if the pivotal instant arrives on October 29th, marking the point where Atlas opts to remain rather than depart, then preparation for the ensuing developments becomes essential. And currently, we're far from equipped. There's no strategy in place, no dedicated entity exists to manage such a circumstance. We lack even agreement on the need for concern. Loeb's irritation over this unpreparedness shines through vividly in his discussion. He repeatedly stresses the urgency of addressing it with gravity. Regardless of the slim odds, even a mere 1% likelihood that Atlas represents advanced technology, the consequences could be profound enough to demand top priority handling. Resources ought to be rallied. Conversations at the uppermost echelons of authority should explore responses to an extraterrestrial arrival proving far beyond a mere asteroid. Yet the reactions from experts in the field have largely brushed it aside. Dismissals label his notions as absurd. Accusations fly that he's merely seeking the spotlight. Claims arise that merely suggesting extraterrestrial origins undermines the integrity of legitimate celestial studies. Loeb's rebuttal, however, remains straightforward. Inquiry must chase the clues, not preconceptions. The clues surrounding Atlas, though not definitive, carry peculiarities sufficient to justify scrutiny. Its path deviates from norms, its bulk exceeds projections, its schedule feels suspiciously apt. Its observed form shows oddities. Any single element might find a rational accounting, yet combined, they form a configuration meriting focus. That October 29th event, the closest solar approach obscured by the sun, signals the onset of revelations. Should Atlas reappear in late November along its inbound path of retreat, it likely qualifies as an ordinary comet, eccentric, no doubt, but inherently mundane. Tension could then ease universally. Conversely, should it return via an altered route, with its path modified or no longer receding, an astonishing shift will have occurred. At that juncture, discerning whether Atlas stems from natural forces or engineered origins will surge in immediacy. Chapter 8. Gear up for every outcome. Loeb highlights a subtle yet crucial insight during the talk. He notes, "It could come to save us or to destroy us. We'd better be prepared for both possibilities and verify that all interstellar objects are just rocks." This remark captures his core outlook on engaging cosmic intruders, neither naive hope nor irrational dread, but methodical scrutiny and openness to the entire range of scenarios. The rescuer narrative dominates popular visions of initial encounters. A society capable of crossing voids would, one assumes, have transcended the perils endangering nascent worlds, shortages of essentials, ecological ruin, wars of annihilation. They would exist in abundance, harmony, wisdom beyond our grasp. Such beings might impart their wisdom, innovations, cures, remedies for our predicaments. This outlook inspires optimism, a federation of worlds, cordial sharing of insights across kinds. And it's far from unattainable. Should sentience proliferate across the cosmos, should engineered societies emerge often, then surely a portion evolve toward benevolence. They master their ruinous impulses, they forge enduring, tranquil realms, extending aid to fledgling ones instead of menace. Yet the annihilator prospect holds equal weight from another angle. Here, the dark forest theory weaves in, though Loeb avoids lingering on it excessively in the conversation. At its heart, the cosmos offers limited bounty: suns, worlds, unrefined elements, power sources. If aware beings in a universe where resources prove scarce, rivalry over them becomes unavoidable. Should you come across an alien society, a core dilemma arises. Their motives remain unknown. Uncertainty lingers about whether they approach with benevolence or hostility. Questions persist on if they seek to vie for supplies alongside you or aim to wipe you out in advance. Under such circumstances, the most secure approach could involve launching a preemptive assault, obliterating any budding society you spot prior to its rise to a level capable of endangering you. This stems not from spite, but from logical self-preservation. Such a stark equation feels bleak, yet it holds reason. Loeb refrains from advocating this outlook. He avoids claiming it as his prediction, yet insists we must not dismiss it entirely. Should Atlas qualify as a probe with technological origins, its creators and directives stay mysterious. It might serve as a benign scout or harbor far greater perils. Hence, his stress on readiness. Preparation demands readiness for each outcome. Protocols must exist to guide interactions should the arrival prove amicable, alongside defenses should it turn adversarial. The hurdle lies in our lack of readiness for any case. No shared protocol governs sending signals to alien minds. Lacking worldwide agreement exists on our message content or humanity's representative voice. Defenses against a superior tech hazard, should it emerge, remain absent too. Our mightiest arms, like nuclear warheads, offer little against something Atlas-sized. Even supposing interception proves possible, which it doesn't given its velocity, shattering a 20-kilometer entity would spawn countless lesser chunks, all barreling toward impact, exacerbating the crisis rather than resolving it. Should Atlas possess engines for maneuvering, hitting it grows vastly harder. An evasive, shifting mark defies strikes from our current arsenal. We'd require tools beyond our grasp, perhaps directed energy arms, such as potent lasers or particle streams, devices beaming force at light's pace to deny escape windows, yet those elude us. None exist at the magnitude to impact a colossal form, nor with the necessary energy yield. At least decades separate us from such prowess, possibly centuries. Thus, a belligerent Atlas leaves us with scant choices. Attempts at dialogue, bargaining, or persuading its operators that we pose no danger remain options. Failure there exhausts our plays. Loeb pushes vigorously for a global body to manage these eventualities, as vital choices and potential deeds cannot rely on solitary countries operating alone. Unity demands orchestration. A collective human stance proves essential. He likens this to broader earthly crises. Tackling climate shifts calls for cross-border teamwork, since one nation's outflows impact the globe. Curbing nuclear spread needs pacts and oversight, as a single defiant power armed to the teeth endangers all. Outbreaks demand synchronized health efforts, given pathogens ignore frontiers. A star-spanning arrival, benign or bellicose, poses a deeper trial still. It transcends individual or state concerns. As a world affair, it calls for a world solution. Yet currently, no framework supports this. United Nations panels address space ventures and Earth protection. Their gaze fixes on rocks from space and junk in orbit, ignoring starfarers. No entity dedicates itself to scanning for tech traces or orchestrating replies to possible encounters. Loeb urges a shift. We need an entity equipped with the power and capabilities to monitor celestial wanderers from beyond our solar system, scrutinize them for indications of artificial origins, and offer guidance on appropriate reactions must exist. This body ought to operate globally, incorporating delegates from leading nations engaged in space exploration, alongside contributions from experts in the field. Moreover, it requires defined procedures and flowcharts for decision-making. Upon identifying such a signal, we follow that path. Should we witness particular actions, we advance to the corresponding response tier. Lacking these guidelines leaves us navigating without direction. We improvise on the spot. Confronting an event as momentous as initial encounter with extraterrestrial minds, improvisation spells catastrophe. Loeb emphasizes the importance of confirmation as well. He insists on confirming that every such visitor is merely a stone. Rather than presume, we must confirm. This involves meticulous scrutiny, assessment of characteristics, detection of irregularities, and in-depth probes into oddities rather than brushing them aside. Here, his suggested Loeb scale reemerges as crucial. Each interstellar arrival receives a score from 0 to 10 according to the count of peculiar traits it exhibits. Scores exceeding 5 initiate a joint global monitoring initiative, mobilize every telescope at hand, every probe nearby, deploy utmost resources to profile the entity and ascertain its essence. Regarding Atlas, such an initiative ought to be in full swing by now. Numerous observatories should be locked on its path. Efforts must synchronize data from Martian satellites, from JUICE, from Juno. As proximity increases, real-time collection and examination should occur, seeking evidence of conduct alien to ordinary matter. Nevertheless, according to Loeb's account, this falls short of reality. Scattered efforts persist, with separate groups employing Hubble, Webb, and terrestrial instruments. Yet no integrated operation, no overarching direction, no methodical push to resolve Atlas's true identity unfolds. A key issue stems from astronomers' widespread belief that it amounts to nothing but a comet. They note the surrounding haze, the streaming appendage, the vapor release, and deem it ordinary. Matter settled. With that verdict in place, motivation to continue surveillance wanes. Attention shifts to the subsequent curiosity. Loeb counters that such a judgment arrives too soon. Indeed, Atlas displays comet-like qualities, yet it harbors aspects that resist easy categorization: its path, its bulk, its arrival schedule, its composition. These deviations persist despite the discovery of a tail. They endure. They demand clarification. Until solid rationales emerge, until natural mechanisms fully explain every irregularity, the file remains open. Vigilance must continue, measurements persist, inquiries endure, for the peril of error, of relegating a true artificial emissary to mere icy drifter, defies quantification. We forfeit insights from a superior society. We squander prospects for dialogue. We overlook alerts should the arrival prove adversarial. Loeb's exasperation rings clear in these discussions. He senses his alerts echo unanswered, highlighting a scenario dismissed by all. He recognizes that should his view prevail, should Atlas reveal itself beyond inert debris, hindsight will question our reluctance to probe deeper while opportunity lingered. Chapter 9. The Scientific Backlash. The counter-perspective demands attention as Loeb's assertions arise amid opposition. They have stirred intense reactions within astronomy circles, often laced with sharp rebuke. NASA's Tom Statler, functioning as the AWI's specialist for minor celestial forms, stands among the fiercest detractors. He has asserted time and again that existing evidence unequivocally indicates Atlas as a typical comet's behavior. Fluctuations in luminosity, emissions of gas, the emergence of a coma. Everything aligns with the anticipated response of a frozen nucleus warming as it nears the star. No data from the sightings demands the assumption of extraterrestrial engineering. Statler emphasizes the unpredictable nature of these celestial wanderers. Those originating within our solar system often display behaviors that appear odd until the underlying mechanics become clear. They fluctuate in brilliance unevenly due to varying regions of frost vaporizing. Streams of material erupt, altering their paths in unforeseen manners. Pieces break off and reassemble. Such chaotic, intricate entities are what comets represent, and Atlas embodies this archetype without deviation. The premature glow, which prompted the first assessment of 20-kilometer diameter, arises from an expansive envelope of particles developing at a great distance from the Sun. Should Atlas contain abundant fleeting materials, those that evaporate under mild warmth, it might initiate gas release sooner than ordinary examples. This process would generate a luminous haze of vapors and grains, rendering the body appear larger than its actual dimensions. The path's conformity to the ecliptic's orientation, that rare one in 500 alignment, proves less extraordinary upon accounting for detection preferences. We tend to spot intruders traversing the central solar realm close to the orbital layer of worlds, since that's the focus of our observational arrays. Intruders arriving at sharp inclines orthogonal to the ecliptic could traverse the system entirely undetected. Encounters with several planets in proximity might stem from the same selective noticing. Interstellar visitors grazing planetary vicinities draw our attention for their intrigue. We publish studies on such events. We direct instruments toward them. Those avoiding significant flybys could slip past without documentation or discussion. Chris Lintott of Oxford University has voiced his dissent with greater directness. He dismissed Loeb's notion of alien tech as utter rubbish. In his view, suggesting otherworldly causes for occurrences with plain earthly rationales constitutes poor methodology. It echoes the contemporary folly of spotting aerial gleams and presuming spacecraft over prosaic alternatives such as planes, orbital craft, or weather effects. Lintott, alongside fellow experts, notes, this marks not the initial instance of Loeb advancing theories of interstellar rocks as alien artifacts. He pursued a similar line with Oumuamua in 2017, positing its odd thrust stemmed from a solar sail, a delicate mirror propelled by stellar rays. Fellow stargazers roundly rebuked that idea, demonstrating ordinary gas venting accounted for the motion equally effectively. Detractors highlight a recurring tendency. Loeb seizes upon any cosmic drifter, showing minor quirks and leaps straight to extraterrestrial origins. Such tactics smack of hype. They chase spotlight and erode trust in genuine inquiries into cosmic life. Researchers tied to SETI, the quest for extraterrestrial minds, express deep irritation. Groups like the SETI Institute commit to unearthing signs of distant societies by tuning radio dishes toward remote suns. They approach the pursuit with gravity. They adhere to strict standards. They refrain from assertions lacking firm proof. Yet Loeb arrives, proclaiming each peculiar asteroid a potential scout from afar. Abruptly, the discipline appears diminished in stature. Doubters of SETI, those deeming alien hunts a squandering of effort, cite Loeb's assertions as proof the endeavor veers into quackery. The SETI cadre's exasperation arises from their commitment to precise, systematic inquiry, undermined by Loeb's prominent conjectures that complicate their endeavors. Detractors find it simpler to brush them aside. Such skepticism renders it simpler for grant providers to slash allocations and for ordinary folks to conflate valid inquiries with outlandish notions involving unidentified flying objects and extraterrestrial visitors from antiquity. Yet Loeb maintains a steady rebuttal to these objections. He contends that empirical findings ought to guide scientific pursuits rather than worries over prestige or public perception. When observations hint at the extraordinary, pursuit is essential, regardless of whether the notion disquiets us or upends our preconceptions regarding probability and feasibility. He highlights numerous instances from scientific annals where prevailing views proved erroneous. For years, the concept of continental drift faced outright rejection as implausible until proof mounted irresistibly. The notion that microbes might trigger stomach ulcers met with derision prior to validation. Black holes, once deemed mere theoretical abstractions devoid of tangible existence, gained acceptance only after observations confirmed them. In each scenario, advocates of these fringe concepts endured scorn, ridicule, and accusations of harming their disciplines. Yet, ultimately, their positions prevailed. This success stemmed not from superior intellect over detractors, but from adhering to evidence over majority opinion. Loeb aligns himself with this lineage. He avoids assertions of absolute truth. He refrains from declaring Atlas unequivocally as extraterrestrial engineering. Instead, he posits its peculiarities warrant meticulous scrutiny, and we must not reject the prospect merely due to its apparent improbability. Furthermore, he advances a practical rationale. Should the odds of Atlas representing artificial origins stand at a mere 1%, the potential ramifications demand attention, for mistaking it for an ordinary comet and overlooking a true brush with otherworldly minds constitutes an irreversible error. The entity would depart, the chance evaporate, leaving humanity to ponder the oversight through eternity. Conversely, rigorous examination yielding a natural verdict incurs no real loss beyond allocated observation hours and analytical labor. Treating a commonplace phenomenon as potentially artificial yields negligible expense. Overlooking an artificial one by presuming natural origins exacts a colossal toll. Loeb insists this imbalance demands a recalibrated stance. Caution favors deeper probes. Every cosmic interloper merits close inspection, particularly the atypical varieties, with natural attributions reserved until other options stand excluded. Mainstream scholars, however, adopt a contrasting view. They regard funding and observational slots as scarce commodities, unfit for fruitless pursuits. An entity resembling a comet in form, behavior, and attributes, backed by a plain earthly rationale, qualifies as such. Proceed accordingly. At core, the contention hinges on divergent principles for scientific methodology. Do we prioritize restraint, clinging to accepted interpretations absent disproof? Or embrace curiosity, weighing atypical scenarios alongside routine ones? Loeb commits resolutely to the latter path. He prefers probing 100 mundane items for signs of artifice, unearthing zilch, over bypassing a singular authentic case through hasty rejection. Detractors lean toward prudence. They insist on robust proof prior to indulging radical propositions. Fairness compels acknowledging their validity. Proposing an interstellar wanderer as alien contrivance qualifies as audacious. It would reshape views on cosmic life's prevalence. It would affirm solitude's end. It would provoke deep inquiries into the Creator's motives and prowess. Bold assertions necessitate compelling substantiation. To date, indications of Atlas's artificial nature fall short, remarkable, yet merely hinting at possibilities. The path it takes stands out as peculiar, though feasible. Its weight seems substantial, yet aligns with a compact, icy body. The appearances catch the eye in odd ways, but they can be accounted for. The makeup is peculiar, still falling inside typical organic differences. No aspect of Atlas outright declares it man-made. Thus, skeptics maintain we ought to favor the straightforward interpretation. It hails from a distant stellar neighborhood as a frozen wanderer. A fascinating specimen, undoubtedly deserving of examination, yet in the end, merely a cosmic entity obeying universal principles. No extraterrestrial involvement necessary. This positions us amid ambiguity. Our collected evidence fails to settle the debate definitively. Atlas might originate naturally. Alternatively, it could stem from advanced engineering. Insufficient details prevent a firm conclusion. Such ambiguity drives Loeb to advocate relentlessly for additional sightings, precise gauging, and thorough analysis. Only through enhanced evidence can we clarify the mystery. Chapter 10. What lies ahead? At this juncture, we find ourselves. The month of October commences freshly. Atlas remains discernible against the evening heavens, albeit dimming while nearing the sun amid rising solar brightness. In the coming month, responses to accumulating inquiries from this saga will emerge. The initial key event arrives on October 3rd. There, Atlas achieves its nearest pass by Mars, skirting just 29 million kilometers from the Crimson World. NASA's Mars Reconnaissance Orbiter stands prepared, its high-rise camera trained on the outsider from afar. The imaging clarity ought to distinguish the central core from the encircling haze, offering our sharpest glimpse so far into Atlas's inner form. Should HIRIS uncover a core exceeding 5 kilometers in diameter, verifying a span nearing 10 or 15 kilometers, it bolsters Loeb's case regarding the weight discrepancy issue. An expansive yet comparatively light form that withstands deviations from vapor releases begins resembling less an ordinary ice traveler and more an item of deliberate design. Should the core prove compact, merely a couple of kilometers or smaller, the projected 33 billion T-mass figure could warrant adjustment. Perhaps the estimation technique harbors inherent flaws. Perhaps the vapor emissions prove uneven beyond expectations, generating propulsion that offsets unexpectedly in unconsidered manners. A diminutive core would steer Atlas toward the commonplace icy wanderer theory. ESA's Mars Express and ExoMar Trace Gas Orbiter will likewise scrutinize Atlas amid the Mars Pass. They will employ spectral analyzers to probe the haze's makeup, seeking compounds that could reveal Atlas's birthplace and materials. Increased carbon dioxide, heightened cyanide, or unforeseen elements. Each reading enriches the overall image. Beyond that, a slim yet tangible chance exists that Atlas could release an element amid the Mars rendezvous. A compact scout, a surface settler, or any fragment detaching from the primary form to adjust trajectory toward Mars. Loeb determined the required launch speed would remain modest, only several km/s. Observers on Earth likely would miss it. The item would appear minuscule, dim, yet satellites circling Mars could spot it, particularly during active navigation. Does this seem probable? Hardly, with near certainty against it. Still, such an occurrence merits vigilance, for should it occur, should a piece detach from Atlas and veer planetward, that would transform everything. It would signal artificial origins beyond any organic mechanism. Post-Mars rendezvous, Atlas presses sunward. Across October it draws nearer the star, glowing more vividly overhead, yet increasingly elusive amid encroaching solar dazzle. Earthbound scopes will forfeit view by mid-October. Orbital observatories may persist somewhat further, though even they will falter as Atlas nears within several degrees of the Sun from our vantage. The timeline advances to October 29th, marking perihelion as the pivotal juncture. At this stage, Atlas attains its minimal distance from the Sun, roughly 1.4 astronomical units away, positioned slightly within Mars's path. Positioned directly opposite Earth relative to the Sun, it remains concealed and beyond direct scrutiny. Should Atlas execute any adjustment, this represents the prime occasion for such action. This timing offers the ideal conditions for a retrograde perihelion thrust. By harnessing solar gravity to enhance propulsion outcomes, even a modest velocity shift here could shift the path from a hyperbolic outbound course to a stable elliptical loop around the Sun. Observers will miss the event in the moment. Real-time detection of the adjustment proves impossible. Only later, upon Atlas's reappearance from solar occultation in late November, will orbital recomputations reveal the truth. A altered course, one no longer fleeing the system, would signal a profound development. As November unfolds, a fresh observational cycle commences. ESA's JUICE probe, en route to Jupiter yet still nearer the Sun, secures a prime vantage for Atlas's exit from conjunction. JUICE employs an array of tools, cameras, spectrometers, particle sensors, for comprehensive monitoring. Data transmission lags due to the probe's remoteness from Earth and its modest bandwidth setup. Yet by February 2026, in-depth readings from this interval should reach us. Should Atlas display heightened post-perihelion vigor, such as intense outgassing or erratic luminosity shifts, JUICE could document it. Evidence of engineered intervention, deviations unexplained by typical cometary behavior, would surface here. In late November through early December, Atlas draws nearest to Earth. This proximity, at 1.8 astronomical units, or about 170 million miles, avoids any collision risk yet allows superior telescopic resolution. Instruments like Hubble Webb and Earthbound facilities equipped with adaptive optics will train on Atlas across various spectral bands. This interval provides the premier opportunity to profile the entity exhaustively, assessing spin period, form, makeup, and probing for irregularities that challenge standard comet interpretations. Subsequently, Atlas proceeds beyond Earth, veering toward Jupiter's orbital zone. Come March 2026, NASA's Juno mission will scrutinize it during the Jupiter flyby. This affords yet another prospect for proximate analysis, potentially uncovering overlooked traits from prior exams. Beyond that, Atlas's fate diverges. It might depart the solar system along its hyperbolic arc into the void of interstellar realms or settle into a sun-bound ellipse forged at perihelion. In the former case, we track its gradual dimming until it slips from detectability, cataloging it among interstellar transients. A captivating enigma that, in the end, aligns with natural origins. Should it linger, the implications transform utterly. A self-inserted interstellar wanderer, whether by intent or chance, integrates as a lasting solar resident. This opens avenues for prolonged scrutiny over years or generations, missions dispatched for intimate encounters, and perhaps reciprocal signals if outreach elicits response. Loeb's consistent message across this dialogue and his broader commentary on Atlas underscores preparation for both scenarios. Vigilance in monitoring remains essential. Robust datasets demand collection. Readiness to adapt follows if the entity reveals itself beyond mere inert stone, for this heralds the onset of greater revelations. With the Vera Rubin Observatory now active, it surveys the heavens with remarkable speed. Thousands of fresh asteroids emerge from its sweeps. Within those finds, additional interstellar arrivals await discovery. Such visitors from beyond our solar system could arrive sporadically, perhaps at intervals of several months or with greater frequency should they prove abundant. Every instance presents a unique prospect for examining substances originating in distant stellar realms, for gaining insights into planetary development across various galactic regions, and, who knows, perhaps even for discovering artifacts not shaped by ordinary cosmic forces. Loeb urges a methodical approach here, advocating that we evaluate each extraterrestrial wanderer according to his framework, probe the peculiar examples in depth, and refrain from overlooking potentialities merely on account of their apparent improbability. After all, the cosmos brims with unexpected twists, and our gravest error would involve ceasing the search simply because we presume familiarity with forthcoming revelations. Atlas serves as a prime example. It marks the third such extraterrestrial arrival we've identified, and undoubtedly the one sparking the fiercest disputes. The discussions surrounding it, along with the clashes between Loeb and his detractors, are shaping the manner in which we tackle subsequent finds. Shall we adopt a cautious stance, favoring ordinary origins until compelled to entertain other options? Or pursue a venturesome path, scrutinizing meticulously while maintaining receptivity to novel ideas? This choice holds significance, as it influences our very perceptions. Should we presume all phenomena arise naturally, every datum will pass through that filter, causing us to overlook signs of artificiality even when they appear. Yet, an overzealous hunt for extraterrestrial intelligence in every shadow would squander efforts on misleading trails and erode our authority. Striking equilibrium proves challenging. It demands sound discernment, it calls for adhering to evidence over ingrained biases, and it insists on modesty, recognizing our incomplete knowledge and the cosmos's capacity to astonish beyond our wildest conceptions. Regardless of whether Atlas emerges as a mere comet or harbors greater secrets, it has already imparted a key lesson. It has demonstrated that these interstellar travelers transcend mere hypothetical wonders. They exist as tangible entities we can observe and analyze. Moreover, certain among them exhibit traits so atypical as to compel a re-evaluation of our foundational beliefs. Such inquiry, this readiness to examine oddities with precision rather than brush them aside, embodies the essence of scientific endeavor. Not an uncritical embrace of extreme notions, nor an instinctive dismissal. Rather, precise scrutiny, reliable gauging, and forthright interpretation of evidentiary revelations. The coming months loom as pivotal. October 3rd, October 29th, late November, early December. These junctures deliver fresh evidence, additional sightings, further elements of the enigma, so that by year's close, a far sharper image of what 3 Atlas truly constitutes will emerge. In the interim, we observe, anticipate, and ponder. This account has delved into one of the solar system's most captivating detections, a cosmic interloper that tests our comprehension and expands the limits of conceivable realities. Whether Avi's theory holds water or Atlas reveals itself as an extraordinary yet inherently organic comet, the inquiries it provokes run deep. We have traversed the path computations, the unlikely probabilities, the estimates of mass, the irregular visuals, the enigmatic compositions. We have absorbed Loeb's contentions alongside rebuttals from his opponents. We have contemplated the implications should Atlas bear technological origins and the appropriate responses. Atlas's tale remains unfinished. October 29th approaches. On that occasion, as Atlas slips sunward and either persists or departs, our grasp of our cosmic position will sharpen ever so slightly. Thank you for joining me in unraveling this enigma. Should this thorough examination have resonated, please consider liking and subscribing for similar explorations ahead. The cosmos teems with enigmas, and our journey into them has only begun. Before signing off, I ought to note that all the assertions explored in this discussion stem from openly shared information and established studies. The analysis of such details, especially Loeb's theory on possible artificial sources, continues to divide experts in the field. The consensus among most skywatchers holds that Atlas qualifies as an ordinary comet, making it the leading probable account. Nonetheless, the peculiarities do exist, the inquiries carry weight, and the exchange deserves to continue. Nurture your sense of wonder, direct your eyes skyward, and recall how the cosmos has caught us off guard previously and surely will in the future. Good night.